Good afternoon and welcome to this webinar, Whole Building Decarbonization, Insights from Industry Experts. This event, brought to you by the ACHR News and Engineered Systems, is sponsored by Trane. I'm your moderator, Kyle Gargaro, Editorial Director of the News and Engineered Systems. Thanks for joining us. Today's presenters are Trevor Jolson, Aaron McConaughey, Mike Fierro, Charles Geelan, and Andrew Blake. Trevor is the industrial lead for Trane's decarbonization program for key accounts. Through this program, he collaborates with industrial customers to define their environmental sustainability objectives and establish initiatives to reduce operational emissions through financially attractive and measurable projects. Trevor's subject matter expertise is in the energy markets and how the supply side of the energy connects to the built environment. Erin is a principal in mechanical engineering with ARUP. She currently leads the Global Net Zero Carbon Working Group and America's Building Decarbonization Climate Services Team. Erin is a professional engineer in California and Colorado, a LEED accredited professional with B, D, and C specialty, an ASHRAE accredited high performance building design professional, and a fellow at ASHRAE. She is also co-author of the ASHRAE Natural Ventilation Design Guide and writes semi-annually for the Engineer's Notebook column in ASHRAE Journal. Mike is the National Mechanical Supply Chain Manager for SourceBlue. In his more than 20-year history, his industry experience has included a focus on evaluating mechanical design criteria, offering alternate solutions, producing project-specific equipment scopes, bidding and negotiating equipment purchases, coordination and follow-up for on-time equipment factory testing and delivery, and overseeing equipment testing and vendor startup. Charles is the Decarbonization Program Manager for Trane. He has been involved in the development and support of HVAC systems for Trane since 2012. His areas of expertise are in hydronic systems, refrigerants, system modeling, and decarbonized system designs, including the electrification of heating. As a decarbonization program manager, Charles has responsibility for key account decarbonization and customer project support across North America. And Andrew is the Environmental Services Commercial Director at AGAS. At AGAS, he focuses on the development and sale of voluntary and compliance carbon credits associated with the destruction of end-of-life refrigerants and reclamation of HFC gases. For the last 10 years, he has worked in carbon markets, climate change, and corporate emission reduction strategies in Europe and in the US. In addition to his work with refrigerants and high GWP gas offset projects, Andrew also has a background in international nature-based solution carbon projects. Don't forget to submit your questions, and later in the program, our presenters will address as many as possible. Today's event is being archived and recorded and archived at achrnews.com/webinars. And now I'm excited to turn over to today's first presenter. I believe you're first up, Trevor.
I am indeed, Kyle, and I appreciate that intro. I don't know about everyone else, but I'm really jealous of your voice, Kyle, and I'm trying to go deep here to live up to it and keep the audience engaged. But appreciate that very warm introduction, and happy Tuesday to everyone. So unfortunately, I didn't make the main stage for today's presentation. I am simply the opening act for the subject matter experts that we pulled together. So had to do a little bit of research on the greatest opening acts ever. And a fun fact is that the Beatles were the opening act for Roy Orbison in 1963 until they became so popular that they took over on that tour over in the UK. So I'm using that to kind of set the stage for the short time we have together to give a really empowered presentation. Where I want to start the discussion is on a chart that is a hockey stick graph. And I want to explain what we're all looking at here, which is the uptick in the amount of companies that are disclosing their emissions data. So today we're going to be looking at total decarbonization strategies, but there's a lot of drivers behind why corporations and buildings are starting to look into decarbonization. The chart you're seeing on the screen here shows that over the course of the decade, more than 20% compound annual growth rate of companies that are starting to be open and transparent about their emissions. I was reviewing the ACHR news website just today, and there was a great example of a story of two companies that are kind of a leader in this space and show up on that A list of CDP companies. There's a story about Amazon as well as Target and how they have started to lean into CO2 refrigeration as part of their net zero ambitions. But they're really just two of 13,000 enterprises that are now starting to report out on their emissions every single year. What we're going to do is we're going to break down those different emissions. We're going to talk about what's important to those companies, and we're going to share an entire life cycle of how those companies are going about managing their emissions. So a little bit more on the why. Why are companies and buildings starting to focus in on decarbonization? The first is that they want to lower their life cycle operational cost. Being able to reduce the cost of the building over the course of its lifetime has significant value that adds to this third step here, which is creating asset value and creating brand value. And then that middle is really about removing business risk. It's becoming understood that having emissions that we're accountable for as a building or as an enterprise is a risk that we carry. And that risk can limit our potential for growth as a business or to be able to pull tenants in. So I want to share an idea of how some corporations and how businesses are going about evaluating this risk and putting a number to it. There's this concept out there of carbon pricing, where organizations are actually evaluating just how much risk the emissions are to them or the opportunity that they can gain from moving into a low carbon environment. So I'll very quickly kind of break through this here. When we're doing energy efficiency projects, we all know that we're looking at how an ECM has a simple payback. When a company or a building carries a carbon price, what they're starting to do now is add an additional payback lever that is looking at the CO2e that can be reduced in a project. So if our customers are starting to look at ways that they can reduce emissions, and they're starting to bring a carbon price to the table, it gives us an opportunity to bring the projects forward that have the highest impact and are most supportive of our customers' goals. And we also have this kind of regulatory stick that's out there that I think we're all seeing and is probably why we've brought such a significant audience together today. There are policies that are coming out at federal, state, and local levels that are driving advanced decarbonization. We call out here, I think the most prominent is what's happening in New York City. For those that have facilities in that area or operate in New York City, you may have some familiarity with what's called Local Law 97. We just talked about the idea of a carbon price. In the case of Local Law 97, it's more of a carbon tax or a carbon fine for buildings that are using emissions above a certain cap or a certain level. So if we go back to that idea of business risk and eliminating business risk, if we're driving emissions out of our buildings, we are setting up to be better positioned for this regulatory change that we can all see coming right now. There's also another big trend, and one of the topics we're going to hit on today is electrification. We're starting to see cities actually go so far as to ban new natural gas hookups. So as we go through the life cycle of the building, we have to be prepared to fully electrify those buildings or to use a different fuel source than natural gas because it's not going to be available to us. And with that, I want to pass over to our first subject matter expert that is on the design and engineering phase, the very first component of the life cycle of a building. And Aaron, would love for you to go ahead and take the stage and wow the audience.
Thank you very much. Hello, everybody. Today, we're going to build off of what we were just talking about and understand sort of a more global aspect. Why are all of these cities making all of these laws? Well, it's because what we know is that 28% of global emissions comes from just the operation of buildings. And so if we're going to sort of meet our Paris Agreement goals, we really need to collapse that amount of operational carbon emissions to zero as much as possible. But we also have to keep in mind the amount of carbon emissions that are associated with embodied carbon. Somewhere between 10 and 11% globally come from the fact that we are in the construction business. So codes and standards are coming out in order to support that. Some of the ones that you see on the screen are the voluntary standards and some overlays for the current code cycles of the ICC. So if we're planning for 100% renewable energy as the basis of transitioning through electrification to lower carbon emissions, we really need to understand that there's a lot that sort of private property owners can do in order to use energy efficiency to drive down peak kilowatts on their property, within their property line, in order to make headroom in order for the kilowatt hit that you're going to get from electrification or even from EV charging. And all of this is contingent on understanding the trajectory of what the local utility grid is doing with regards to decarbonization. That is a very much a state-run or a municipal utility-run trajectory in terms of how fast they will transition between now and, say, 2050. So very important in supporting our clients to understand when to electrify, not only sort of a trajectory to do that in the future of new designs. Because a lot of our clients are needing to report, especially publicly traded clients, are needing to report with regards to their environmental, social, and government, or ESG structures using the GHG protocol, or the greenhouse gas protocol. And the way that those are reported is through 3 scopes. Scope 1 is the emissions that you release from your own property. Scope 2 is the emissions released on your behalf from your purchased utilities, which is why it's important to understand what your electrical grid is doing and to be concerned about what might be burnt on your behalf with regards to natural gas there. And then scope 3 is kind of the everything else that a corporation might have, from travel to other materials that are coming in and out. And so the thing to understand is, as we move from a mixed fuel system to an all-electric system, if we do it too early, we might actually be having more emissions, depending on kind of what the carbon intensity of the electrical grid is right now, say if it's on coal-fired plants as opposed to natural gas plants. So, but overall, we anticipate that in the majority of locations, eventually, we will move from our current status, which is about 50% of the operational carbon of existing, about 50% of the emissions of an existing building being from operational carbon, about 50% coming from it having had embodied carbon. As we design high performance buildings, that operational carbon piece of the pie will reduce. And then as we get onto 100% renewable energy sources, all we will be concerned with will be embodied carbon. And so what do we do about embodied carbon? Well, we need to start thinking about the value of the mass that we have extracted out of the earth and figure out how to use it in as many times as possible, right? Either recycling it or repairing it in situ, or even just reusing it in a different building while it still has value and capability to operate. And one of the things that we use when we start thinking about this circular economy is, which of these different layers of the building, they're called shearing layers, can be kind of easily removed, cleaned up, and put back in place, or put in place for equivalent use in a different building. And you see sort of the 5 S's up here. You move from site to structure, which has a long life, to skin, which has about a 20-year life, services, maybe 7 to 15 years. And then space planning, we have constant churn on our TI. And then the stuff is just, furniture and stuff like that that's changing all the time. So what can we do from a services point of view to ensure that we can reuse, recycle, and repurpose our equipment either in situ or elsewhere to propose this circular economy use to reduce embodied carbon from virgin materials? And so when we look across the entire life cycle, we need to start doing whole life cycle carbon assessments when we do design from the start, because there will be carbon emissions associated with creating products, carbon emissions associated with doing the construction, which we'll talk about in just a second, the emissions that we all know about that comes from being in use and, the use of the electricity or gas, but there's also in use as you do that churn for TI. And then at the end of life, what is the carbon emissions associated with degradation of that material or even shipping it away to a landfill? So we need to understand the whole life carbon when we're designing from the start. And one of the things that I just want to point out here is that it's actually in these middle stages of refurbishment or that TI that is often an overlooked part of the embodied carbon burden of a design. So we need to design from the start in order to accommodate what might be happening in the future. Because what we all know from the design point of view is that your ability to affect future energy use, future embodied carbon use in those changeouts of materials in the future is really contingent on the design decisions that you make at the earliest phase of a design. And we need to be having a plan to match our potential emissions with our potential mitigations, whether they come through renewables or they come through intentional carbon offsets that come with that cost that Trevor was just talking about. And so, this occurs, periodically every 15, 20 years as we change out that equipment, as you can see across the bottom. So we need to bear that in mind as well. So last but not least, during the design phase, it's really important for us to think about the sequencing of our design, or what we call a stacking layer, right? We need to address operational, then we need to look at what our renewable sources are for that energy in order to drive all that operational down to zero, and then start to attacking the embodied carbon for the long run. And only once we've reduced that to consider offsets and alternate means. So I'm going to turn it over to Mike right now to take you to the next step.
All right. Thank you very much, Aaron. So I work with SourceBlue, as Kyle mentioned before, and I work very closely with our parent company, Turner Construction. So in Turner Construction, we have been looking at the emissions that we create during the construction process itself. So we have a chart here that's showing you basically all the emissions that happen during the cycle of a project. This is a snapshot, or the entire project. There was one in particular one, and it shows that we have two in particular spots where we have very high emissions, site and foundation equipment. A lot of this is from the diesel for the generators required to power up the cranes and other equipment that's there. After this, and we get into the actual structure and the finishes, it comes on, and then we have another big spike at startup and commissioning. In here also, there is a large portion of temporary natural gas, typically for temporary heat that does happen. I'm going to touch on that a little bit later in the presentation. So as you can see here, the total diesel emissions is almost 60% of everything that we do. So that is one of the big things that we've been targeting. And a few slides down, you'll see one of the interesting ways that we are trying to reduce that by keeping everything moving. And how do we do this, and how do we get this information? So what Turner Construction has been doing is we've been monitoring projects, and we've been putting meters on the water, electrical use, and the fuel use, right? Whether it's diesel, acetylene, gasoline, natural gas, propane, all the way from when we start with shovels in the ground, all the way through substantial completion. And anything that's within the job site fence for more than a day. And this does include permanent utilities. Sometimes we have to ask owners for bills and stuff to make sure we have that. But how are we doing? We have 97 active projects that we've been metering or measuring, 25 of them now. This is a little outdated. We just finished one last week. And we got 86 more in the future, and 102 under evaluation for this program as well. Because without the information and data, we can't see where we are and evaluate how we can go further and better improve ourselves. So I'm going to go over an example that we did on the diesel side of things. We have a hybrid generator setup that was on a project that we had for Turner. What this does is the crane needed and is designed for a 500 kW setup for a peak load on basically the highest or heaviest pick, right? And is not used very often. So what we did is this hybrid battery storage system has a 200 kW generator combined with a battery storage system. That 200 kW generator combined with the battery, which can charge it over time and get up to the power it needs to, and then those batteries can discharge with the combination of the generator to get that peak power you need, which is not very often, and considerably reduce the amount of fuel and energy that you need. If you can see here, the emissions that we took down was 54% lower, right? And the cost of fuel was also reduced, and the operating costs. So one of the other things that we can do also is the noise was able to be reduced as well. We have problems with that on job sites where overnight generators might have to run to keep stuff moving like lights. With the battery system, you don't need to do that. The batteries could run, no noise, and it'll also even be able to power things like the FAA light. Another example that we're going to show you guys that we're working on right now with one of our vendors is temporary heating. So as you can see here, there is a considerable amount of natural gas used for temporary heating. A lot of that is because we do not have control of the units. If we're using a permanent boiler, let's say, they have to get it up and running. And all they do is say, all right, let's get this thing up and running. We're going to run it 100% just to make sure we have heat on the floors. That doesn't work very well when it comes to emissions. Basically, what this chart says, we got these units under control in May, and you can see this significant drop off in the amount of fuel that we had to use because we had it under control. So we've been working with some of our vendors basically to be able to engineer solutions in the design phase to avoid rushing to procure equipment during this process. Because also, if we're not using the permanent equipment and we have some temporary items, these things are usually rushed to be procured. You have to call up a guy and make sure we can get something there quickly, and they're going to get whatever we have available. It does happen a lot. So doing this work up front and engineering it into the process has significant effect on the emissions we have. So with us and Source Blue, we're able to pre-purchase equipment. We can get it there earlier, we can set it up earlier, and we can have all this stuff engineered. So when we start up the equipment, we could have it under control as well. And that control of the permanent equipment is a huge benefit and can keep these emissions down significantly here. It's like almost 300% that we can drop this stuff down to. With that, I'm going to turn it over to Charlie so he can continue on his section.
All right. Thank you, Mike. Very cool stuff. First, for those of you with some high definition monitors out there, if you can see over my right-hand shoulder, I'm not actually a licensed marriage and family therapist. That's my better half. I'm in her office today. Although I do feel like I have a minor with all the questions I get sometimes. But let's keep going here. So the phase I'm going to start with is building operation. And so there's kind of two avenues that you would start or get into this phase. One, if it's new construction, you've already gone through the design, the construction, and now you're going to turn that building over into operation. Or if you have an existing building, this is going to be your starting point. So how can you reduce your carbon emissions with a building that is in operations today? So to start, we're going to look at where emissions are generated from for your building. And Erin touched on this a little bit in her section. But when we look at operational emissions, there's two buckets that we usually look at. The first one is scope 1 emissions. And so these are emissions at the building itself. So we're going to look at the direct fire, the direct consumption of natural gas at your building. So this is primarily going to be for space heating, for water heating, or for cooking. And then the other scope 1 emission is from refrigerant loss or fugitive emissions. And so if you have mechanical equipment that uses a refrigerant, that refrigerant has a GWP, global warming potential. And you'll take that GWP and you'll multiply it by the weight of the refrigerant that you lost, and that's what you would need to account for in your scope 1. The other bucket is scope 2 emissions. These are going to be indirect emissions and primarily the electricity consumption that you consume by the building. Right? And the emission factor for that utility grid is going to be different across the country, and that's one thing we're going to get into in a little bit more detail in a couple slides. All right, but when we're when we're talking about operational emissions, looking at your building, we're looking at both of these emission scopes and trying to figure out how can we reduce all of them. And so in the space of HVAC and building operation, there's usually 3 levers that we look to pull to lower carbon emissions: efficiency, refrigerant, and electrification. Now on today's webcast, with a little bit of a condensed time, I'm just going to focus in on electrification today because it's a newer topic for our industry, and it has some really big upside that we want to make sure we get across. So the first thing here is just, what is electrification? At its core, it's just a fuel switch. So we're going to go from using primarily natural gas in gas-fired burners and boilers, and we're going to switch to an electric source, right? And designers are primarily looking at electric heat pumps for this duty. The reason we're looking at heat pumps is the efficiency ceiling for heat pumps is much higher than electric resistance. Right? But the reason we're looking at electricity in general is because what's happening at the utility grids around the world. All right, there are large quantities of renewable energy, so more solar, wind, and hydro, that are coming online, and it's kind of changing the dynamics of how we calculate emissions. And so the thought process here, and especially for new construction, thought process is, if we can design for electrification today, that building doesn't have to go through a major change of its internal functions, and it can just ride this wave of green energy that's coming onto the grid. If you're burning natural gas, the thought is that you won't be able to take full advantage of that grid scale renewable energy. All right. Behind the scenes, the commitments that both cities and states are making are big. All right. So what this graphic is showing you is 180 cities and 8 US states have already committed to 100% carbon-free electricity by 2050 or sooner. If you look at Washington State, and the list of states is over on the left, Washington State has a really, really strong RPS, regional or renewable portfolio standard. So they're looking to get to 100% carbon-free electricity for their consumers by as early as 2030. All right, so there's a lot of commitment. There's a lot of people pushing in this effort. This graph is really cool, and it kind of shows you where the rubber actually meets the road. It's showing you year over year net new electrical generation capacity on the US grid. All right, so if we look on the left-hand side, and the scale is in gigawatts of capacity added. Starting in 2000, and you look at the first 5 years there's a lot of gray. And gray is new natural gas facilities, new electric utilities using natural gas to produce electricity, which makes sense because we're converting a lot of coal production over to natural gas. Right, but starting in 2006 and on, you can see that blue bar is starting to grow, and that blue is renewable energy, which is primarily wind, solar, and hydro. And so as far back as 2006, it started to be a significant portion. And if you look from 2016 on, it's the majority. Last year in 2021, 90% of the new generation that we put on the utility grid was renewable energy. And we expect this trend to continue far into the future. Right, so we've got more and more renewables coming onto the grid. Now, electrification, whether you choose to electrify your building or not, might not be your choice depending on where you're at. Trevor touched on this right at the beginning. What this graph is showing you is the states in green, there's 5 of them, already have at least one county or city that has enacted a natural gas ban. It's primarily for new construction. The states in blue have at least one county or city that has proposed a natural gas ban. The really interesting thing about this is it's not just one region in the US, it's not just the coast, this is across the US. And again, this is an area that we'll likely see continue into the future. Now to kind of pivot the conversation to talk about electrification, we want to inform the audience here on the impact that electrification can have. And in order to understand the impact of electrification, we have to understand how the utility grids come together in the US. And so what this map is showing you is a heat map of how dirty or how clean that utility grid is. So the darker the color, the dirtier the grid. And that usually means there's a high percentage of coal that is helping produce the electricity and a low quantity of renewable energy. So if you look on this map, the areas where electrification is going to have the biggest impact today is the lighter colored or the lighter shaded regions. Right. So what we're going to do is we're just going to pick five utility grids. And if you look on the right-hand side, we've got some dirty grids, we've got the cleanest grid, and then a couple in the middle. And we cover north, south, east, and west. Okay. What we want to show you is the progression of the building design. And so what the black bar is showing you is a current building today. So this is what we modeled was a 100,000 square foot office building that uses electricity for the building as a whole and cooling, and then it uses natural gas for space heating. And so the height of the bar is going to be the emissions in metric tons on an annual basis. The blue bar next to it is what would happen if we electrified today, right? And we assumed that we electrified it with heat pumps. What usually grabs people's eye is the SRMW region around St. Louis. If you electrified in that grid today, it would actually be a negative proposition. You would be adding more emissions to the atmosphere. Right? Now, across the board, you look at Minnesota, Oklahoma, Washington, that blue bar compared to the black bar, maybe a 5 to 10% emission reduction. You go to New York and you start to see that we almost get to a 50% reduction in emissions on electrification. And that's because that grid is really clean. All right, but what we can do is project out to the future. Using state RPSs or integrated resource plans from specific utilities, we can get a really good idea of where these regions are going to be in 2030, which is just 8 years away. And that's that last green bar. All right, and across the board, you see significant reductions from the baseline. All right, in St. Louis, SRMW, the electric utility there, Ameren, has big plans to bring on more and more renewable energy. And so going from their baseline to 2030 all electric, you can see their emissions drop in half. All right, across the board, there's big reductions. Now, Washington, it looks like a typo, right? There's nothing there. And that's because by 2030, they're shooting for a carbon-free grid. And if your building's all electric and the grid is carbon-free, that bar drops to zero. All right, so this is the type of analysis we're looking at for electrification. It's not just today, but the life cycle and out into the future of the building. And it's really easy to electrify on paper. It's a whole nother thing to do it in practice, but there are a lot of products out there to help with this. And so what this is showing you is everything from electric resistance. There's electric resistance terminal coils and electric resistance boilers that have been used for a long time. But then on the right-hand side is heat pump offering. Right? And so typically for the products that we traditionally use today, there is a heat pump alternative for it. Right? And so everything in the light commercial, large commercial, and even the larger applied buildings, hydronic buildings, there are solutions in this heat pump space that we can leverage to help buildings transition over to electrification. The last thing here before I hand it off, I only talked about electrification. That is one of the levers we have for decarbonization. You can see the other two, efficiency and refrigerant, are also there to help us. Typically, we start with efficiency. That's that first step, is eliminate waste in the system, become as efficient as possible, and then move on to these next steps. All right, I'm going to hand it off to Andrew to talk about the last phase in the building life cycle, which is end of life.
This is kind of, we have refrigeration units and chiller units in every building all over the world. It's increasing year on year. And it's kind of like a forgotten source of carbon emissions. And I'm sitting right here under a fan, cold. They're everywhere. They're basically they're common in every building in the developed world. And the developing world, there's about 50 million units predicted to be installed over the next 10 years. So what are refrigeration units and what gases are in them? So they've been around for pretty much half of the second half of the 20th century. They started off with CFCs. We realized that they were really bad for the ozone layer in the 1970s, and they were really bad for global warming. And these were in most buildings. So they've been phased out. They were replaced by HCFCs. They're not so bad for the ozone layer, but still pretty bad and cause high global warming potentials. We now currently mainly use HFCs, so these don't damage the ozone layer in the same way, but they've got a very high global warming potential, thousands and thousands of times more than carbon dioxide. And unfortunately, these have been kind of the go-to gases in most buildings, for the last sort of 20 or so years. So they've been phased out in the US over the next decade, really. So they'll be phased out by 2036, I believe. And year on year, there'll be a slight phase down. So I'm kind of basically talking about what A-gas does and how correct refrigerant management and during the life cycle of the units, and then also the end of life destruction at the end of life of the building, how you should deal with those gases. So it's not all doom and gloom. We had in the 1970s they started noticing a hole in the ozone layer caused by CFCs. So in the 1980s, the world got together, and it's probably the biggest environmental success story that's ever happened. I think it's like 190 plus countries signed up to phase out CFCs, which they did. The hole in the ozone layer is now shrinking, and it's predicted by 2070 it'll be back to its natural state. As I said, these are replaced in air conditioning units and refrigeration units in our cars, our planes, in supermarkets, and then of course in buildings. These are replaced by HFCs, and they don't damage the ozone layer, but they've got a very high global warming potential, as I said. So in 2016, the Kigali Amendment was agreed to phase out these HFCs. So that's currently what's happening. That started in the US in 2020, and we're going to phase them out in steps year on year until 2037. They'll still be allowed, they're still allowed in units are there. You don't have to get rid of them, but you're not allowed to import them or create these gases after 2036. So I'm an environmental geek. I love climate change literature. There's this really good book, if any of you are interested, called Project Drawdown. And in it, they basically talk about different sources of emissions around the world, greenhouse gas emissions. And they list, these are done by years of research, and they've listed that correct refrigeration management and destruction at the end of the life is the number one practical way to stop climate change. And it's sort of all of our HFCs in all our buildings and refrigeration systems were managed correctly and destroyed correctly at the end of the life. By the end of this century, we'd probably save about half a degree centigrade in global warming, which, considering this is just one source of emissions, is absolutely incredible. And I just put this, there's a lot of information here, but I wanted to put this in here just to show the graph on the right just shows different regions of the world and different sources of HFCs and air conditioning units. It shows what would happen organically over the next 50 years if there was no regulation in place. And then this black line basically shows with the Kigali Amendment restricting the use of HFCs. This is showing that by 2060, these gases will be down to a minimum. And we just talked about this before, but when you've got your building and you're measuring your scope 1, 2, and 3 emissions, don't forget about the refrigerants are often forgotten about. So scope 1 emissions, when you're installing new systems or cleaning them or repairing them, there's often a leakage. That leakage, because HFCs and CFCs or whatever's in your air conditioning units, because they're so potent, that really does affect your scope 1 emissions. So it's really important to get these fixed and managed properly. There's technology out there that prevents leakage now when you update your air conditioning units. And then, of course, scope 3, sort of 90% of all emissions from refrigerants happen at end of life if they're not disposed of properly. Obviously, it's highly illegal to vent these gases into the atmosphere, but unfortunately, it does happen either by malice or usually just by accident. So, I just wanted to talk about A-gas. So we talking about how potent these greenhouse gases are. We basically collect them, reclaim them, and sell them back to the market, because even though they're bad gases, I'm an environmental guy and I do care, but we also believe that we live in the real world. We can't just ban all our air conditioning units. So the next best thing is to recycle and reclaim and manage them correctly. So A-Gas is a global company. They source refrigerant gases. They'll actually go to your site of an old building, extract all those old gases. They'll take them back. So we've got 2 plants in Ohio and 1 in Texas. They'll clean them, take out all the impurities, and sell them back to the market. So they actually sell it back at virgin specification. And the great thing about that is if you're selling back to the market gases at virgin specification, that stops the need for somewhere in the world for that virgin gas to be created. So kind of like renewable energy, putting clean electricity into the grid, you're preventing dirty coal being created, you're preventing virgin gases to be created. So we basically have 2 ways. We have 2 ways of reclaiming gas and destroying gas. The first one, just going out into your site, collecting that gas, cleaning it, selling it back to the market at virgin specification. There's no difference. So they can, if you were after 10, 15 years of your building's air conditioning units, rather than just phoning up a company and getting virgin gas delivered, you can have your gas actually cleaned and delivered back, or just buy reclaimed gases. And I think the most impressive one is probably the destruction. So they really care about the environment, and I think having your gas at the end of life, rather than just being chucked in a skip or in a landfill, like unfortunately it does, we actually have technology where you can pass these gases, so CFCs, HCFCs, and the HFCs, through this plasma arc, and basically it heats the molecules of the refrigerant gases up at extremely high temperatures and breaks them down into their base molecules. So when you think of the life cycle of a building, buildings may last hundreds of years. Obviously, air conditioning units don't. So when you're going through the process of getting rid of old air conditioning units, just make sure it's done responsibly. This machine breaks down in these gases into their base molecules, and basically what comes out at the end is salt water, a little bit of CO2, and a tiny bit of trace gas. So it's pretty much the most sustainable way of getting rid of old refrigerant gases. The other alternative is you can actually incinerate them. They actually send them to concrete plants where they have furnaces, and you can burn it away. But obviously that releases emissions into the atmosphere. Not as bad as the refrigerants, but still not as good. So it's best to put them through a sort of plasma arc machine to break them down into salt water. Going into the future, so we are saying that HFCs are going to be banned from imports and production in the US, but that's not going to be finished until 2036. So they're going to be with us for a long time. So while that's happening, correct refrigerant management is important. But until then, we've also got a new refrigerant coming into market, which is called HFOs. So these have a low global warming potential, and they also have no impact on the ozone layer. They are a little bit more expensive, but equipment can be retrofitted and these gases can be put into it. Or if creating a brand new building, you want to be putting these HFO systems into your buildings as opposed to putting sort of older refrigeration systems. So I think these gases are pretty dirty, but there's lots of processes out there. So making sure that when you replace your gases, the leakages are not let out into the atmosphere. That you buy and use reclaimed gas. So stop using virgin gas, use reclaimed gas, and then at the end of life, make sure that these air conditioning units are disposed of correctly, either through incineration or ideally putting them through sort of this plasma technology that breaks down the gases into their base molecules. Doing all these things will help building Scope 1 and 3 emissions. And if you timed the refrigerant gas by how much carbon dioxide it represents, one molecule of refrigerant gas is thousands of molecules of carbon dioxide. So correct refrigerant management really does help reduce the environmental and carbon impact of your building. That's pretty much me. So I'm going to hand over to Trevor to carry on, and please feel free to ask any questions later on.
I appreciate it, Andrew. And we have had a really active chat with a lot of questions rolling through, and we have about 15 minutes left. So what I'd like to do is very quickly get into the question and answer portion of the session. We've been looking to address some of the questions that we can via chat, but Kyle is going to call out some questions for the group and ask the subject matter experts that can best address them to do just that.
Yes, absolutely. Great presentation, folks. And we do have a lot of questions. So let's get right to it. This first one is from Jeff. It says, on slide 24, can Charles go a little deeper in his explanation of refrigerant losses within Scope 1 emissions?
Absolutely. So the basics behind this is, let's say you've got a chiller on your facility and you lose 100 pounds of refrigerant. So you replace 100 pounds, and let's say you replace it with 134A. The GWP of 134A is 1,300. And if you lose 100 pounds, you would multiply 1,300 times 1,000, and that would be the pounds of CO2e equivalent that you would have to account for in your Scope 1 emissions for refrigerant.
All right, next question up here is, how has the current supply chain affected clients' goals design choices, and has that impacted more sustainable choices of product and equipment? Sounds like a question for you, Mike.
Yep. And the unfortunate answer is yes. It has definitely affected people and their choices. A lot of clients have gone away from more sustainable choices, and getting stuff on time or speed to market is one of the biggest things on a bunch of our clients that we deal with, especially in the data center world, or even like the battery world for EV plants. So it's not all of them, but that has definitely affected it and pushed people to go toward a not as sustainable option that they can get in a shorter amount of time with parts that are more readily available, let's say, because of the supply chain issues. So it's not everyone, but we have been seeing that. And as the demand hopefully starts to die down a little bit in that area, we're going to hope that that's going to come back on, because there are some clients that will make the right choice no matter what the case, and they will sacrifice the schedule for it.
Our next question from Marissa is directed at you, Andrew. Thanks for the presentation. She says, what is the technology that prevents refrigerant leakage?
Yes, so I'm not an engineer, so forgive me, but when you think of it in a simple way, you've got your refrigeration unit. These can be big racks, or they can be the small domestic ones. Literally puncture the pipes, or if it's got a proper valve, they connect to it. Often, just because of the high pressure, gas can just leak out. But they actually just have a system that reduces the pressure to stop it coming out in the first place and capturing it before it goes into the atmosphere. It basically, and then it also monitors how much has come out. Obviously you can weigh it, but it monitors how much has actually gone out, because a lot of clients will actually want to know. They want to know what their Scope 1 leakage is, so it can actually record that. But as far as I'm aware, the technology actually stops it completely. But if you're at all interested in that, I can get you some information from a proper engineer as to how the technology works in detail. But that's pretty much the gist of it.
All right, sounds good. Charles, Timothy has a question for you. If we use a chiller all year, is it possible to use the waste heat from the chiller to heat the spaces that require heating?
Absolutely. Yeah. If you have a chilled water load all year round, so data center, data closets, maybe you have a process cooling load, anytime you have a simultaneous heating load, you could definitely use that rejected heat, call it heat recovery, to offset some of your heating load, or all of it, depending on the quantity that you have. If we look at some of on the operational side, the levers that we can pull, energy efficiency is typically the first one. And some of the easiest forms of electrification are going to be heat recovery, because you already have those BTUs in your building. Instead of throwing them outside, let's just repurpose them and start to offload some of our other equipment.
All right, stay on your feet here, Charles. Frank has another question for you. What about hydrogen or hydrogen mixtures in gas appliances? Yeah,
hydrogenated natural gas. That's definitely an option. We don't see a lot of it yet today. We hear about it. It's early stages. It's definitely an emerging technology that multiple manufacturers are investigating, and it has some potential. But if we look at forms of clean or cleaner energy today, electrification is typically one that we can point to because there are products available and the utility grid has a clear path to get to carbon neutral or close to it.
Charlie, I'll chime in there if I can and just add my 2 cents. One of the things that does make hydrogen potentially attractive is the technology of an electrolyzer, which is being able to make hydrogen with renewable energy sources directly. So I saw a couple different questions that had to do with how are we going to balance the excess electricity coming onto the grid. And if we can use something like wind power and then balance it with making hydrogen during off-peak periods, it gets more interesting. So being able to connect this entire ecosystem of the electricity grid, there's a big upside there. I think hydrogen will have a role. I don't think it'll be the silver bullet, though.
And then pairing that with fuel cells, right, to produce electricity is be another option.
Absolutely.
All right, Mike, this question's for you. It's from Gene. With the abundance of new construction in New York City, can purchasing renewable energy for battery storage help reduce the use of on-site fossil fuel to help reduce emissions in NYC?
Yeah, absolutely. So when you got the storage on there, again, one of the biggest problems, I'll call it, with renewables is that it's very variable. So when you have a battery system on there, you could balance out power and load and demand very well, and you could reduce the size of your equipment a pretty good amount. And that'll help you out with all those different credits and carbon that you're going to be producing. So the battery is absolutely a great way to go.
All right, Aaron, I want to bring you in one too here. Too, what can Oh, sorry, go ahead.
I was going to say, if you look at where the emissions are typically the cleanest and the dirtiest, usually utility grids are going to bring on their coal plants or their peaker plants in the middle of the day. Anytime we can start to shift away from that period, we're going to see an increase or a reduction in overall emissions. So that's another area where thermal and electrical storage is going to have an impact.
All right, great. Aaron, bringing you in here. What can manufacturers do to support the whole life carbon effort during the design phase?
I think the most important thing is to really understand what the carbon footprint is of the facilities and therefore the equipment that's produced by a manufacturer. That's the emissions associated with extraction of raw materials. So you have to go upstream into the supply chain, understand the energy sources that are used for processing and manufacturing, and understand how that product and all the transport of all that material has been handled, whether it's from a emitting vehicle or from electric vehicles. So understanding all of that will allow you to create what's known as an EPD, or an environmental product declaration, that you can then have as a public document that can be shared with the design community, so that designers can choose between equivalent products from a performance point of view, and embodied carbon becomes yet another performance metric. And I would just offer up that there are public transparency databases such as E3 produced by buildingtransparency.org and the Carbon Leadership Forum that are really trying to make a platform where manufacturers can share this information with the entire industry.
Mike, I'll put you on the spot as a follow-up there. I know that you guys get a lot of requests for EPD data, or it's been a growing request. Can you just comment on that from a customer perspective?
Yeah, I was actually going to jump in there too, Trevor, because Trane is one of the few companies that's been doing it for a long time. A lot of our clients are asking for it, and not very many other manufacturers have it at all. They are starting to work on it, but they don't have anywhere near the amount that Trane does. And again, most aren't even starting with it. They're looking at it now, but it's going to take them years because the amount of effort and work and time it takes to put those things together properly, it takes years. So yes, they are working on it, but they are behind the 8 ball, that's for sure, compared to Trane.
All right, not a bad segue here on Trane. This question for you, Charles, comes from Matt. What is Trane doing to provide suitable equipment for electrification?
Yeah. So like I showed you on that one slide, there's options across the board. So typically, if you have a system that uses natural gas today, maybe take a PTAC, package terminal air conditioner. There's an equivalent heat pump to that called the package terminal heat pump. On the water side or the hydronic side, similar thing. Air-cooled chillers are a big component. We have air-cooled or air source heat pumps, which can go back and forth between cooling and heating. So kind of across the board, there's heat pump equivalents to help customers with electrification. Now, of course, there's challenges and there's hurdles. Anytime you start to look at ambient-based equipment, so air source equipment, minimum ambient operations, trying to get up to some of the hot water temperatures that were designed 20, 30, 40, 50 years ago is going to be a challenge. But that technology is continually evolving, and you're going to see more and more come out from Trane and other manufacturers across the industry over the next 5 to 10 years.
I think it's worth noting, Charlie and I work with large corporations on their decarbonization journeys, and the number one topic we get pulled into by those customers is electrification. And it's looking to, how do I electrify my buildings? Where do I begin? What's the strategy? There's tons of customer pull right now to understand that.
I can keep you on the hot seat, Charlie. This one's coming in from Nick. Traditionally, heat pump type systems struggle to perform in colder temperatures. Can you speak to technology and equipment advancements that provide more reliability or ability to operate in colder temperatures?
Yeah, definitely. Going back to a previous question around heat recovery, that's usually the first step, is keeping those BTUs in the building instead of throwing them away. So anytime we have simultaneous cooling and heating, let's try to keep those BTUs in the building. Beyond that, any sort of water source system, so geothermal systems have been around a long time. Waste recovery systems are becoming more popular. Those types of systems that are water-based and not dependent on the ambient outside are becoming more and more popular. If we go with air source equipment, there are some limitations. Some of the equipment that's leading the industry, if you look at VRF equipment, typically they can provide useful heat into the minus 20s. Some of your more standard rooftop equipment, you're looking at around 15, 20 degrees. Some of the hydronic equipment, 0, maybe single digit negatives. So there are some hurdles for colder climates that we're going to need to overcome. Some of the advancements that we're seeing around the compressor technology, so using staged compressors or vapor or wet injection compressors, that technology is becoming more and more common with new product releases.
Yeah. Hey, Charlie, it's Mike. If I could just jump in there too. I know when you guys are working with design teams, as well as looking at the distribution to be a little different, so that you can use lower temperatures to be able to make those heat pumps a little more useful in the lower temperatures as well.
Yeah, that's a big struggle right now. If you look at water-based systems today, most of them that were designed 20, 30 years ago, where we're replacing that equipment now, they was designed at 160 to 180 degrees. A lot of the technology in the field today doesn't meet that. You're looking at 140 tops. I think ideal heat pumps we would design for 100 to 130 degrees, somewhere in there. There is some technology out there, though, that can get up to those higher hot water temperatures. Of course, you start to balance cost of the equipment with the efficiency of the equipment, because typically as you get to higher lifts, the efficiency starts to degrade. So where possible, we start to look more holistically and try to bring those temperatures down, which usually requires replacing terminal equipment. But again, that's what Aaron does. And so we try to look at this building from full scale, not just one piece of equipment. What can it do? But what can we do for the whole building?
All right, we are running out of time here, but we got a little time for one last question, and that's going to be to Trevor. What are the official reporting channels that are used for commercial businesses to report their carbon?
The chart that I showed at the beginning is the Carbon Disclosure Project, which is the #1 elective participation for emissions reporting. So that's the gold standard that organizations are participating in. There's additional subset that's called the Science-Based Targets Initiative, which is connected to the CDP, and those are companies that are committing to aligning to science for their goals and their objectives. But I think there's a watch for here. The SEC recently came out and announced that they may be making some mandatory disclosure expectations for customers. So we're starting to see a transition from elective transparency in reporting to mandatory emissions reporting, and that's going to be a huge market change. I don't want to end on
That's all we time.
We need something positive to end on, not on the SEC.
We finished strong, I'll tell you that. That is all the time we have questions for today. And let me tell you, there were 6 of us on here. We only interrupted each other twice, and both were my fault. So let me be the first to say, job well done, everyone. Please join me in thanking Trevor Jolson, Aaron McConaughey, Mike Fierro, Charles Jellin, and Andrew Blake for the presentations. And, of course, our sponsor, Train. We very much appreciate it. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console. As you exit today's webinar, take a couple of minutes to complete our survey, please. We strongly welcome your detailed comments. You can also visit achrnews.com/webinars for the archive of this presentation, as well as information about upcoming events. We appreciate your time and hope you found this webinar to be a valuable experience. Enjoy the rest of your day, everybody.